our next presentation is by me, and it's a study with that Teresa was actually the lead on. That was her thesis, and I forgot to mention, but I should say this study was supported by an NSERC Discovery Grant. So that's based around the experiments that I'm going to talk about in a second. So basically, this is a user study, and we are looking at sentiment analysis technology and its impact on decision making. And so the premise is as simple as it sounds. What we're looking at is the role of information in decision making is very well established, right? Typically the conventional wisdom is the more information, the more relevant information you have, the better your decision quality is going to be, until a certain point where that information is, okay, that was worse. That's just incompatible. I'm really sorry, this is what they gave us on this.
It's the HDMI connection.
Yeah. I don't know why it's in this one.
The converters are still not as robust as they should be.
So yeah, the whole idea is that the more relevant information you have, the conventional wisdom is the quality of your decisions are going to improve until a certain point where you cannot process that information. And in the context of what we're interested in, those decisions are purchase decisions, which are very typical decisions that are made for using online information. And the kind of information, the specific kind of online information we're interested in is word of mouth. So word of mouth information has been known to be a good source for helping people make decisions for even before the internet, right? People always used to ask around to see, you come into Montreal, what is a good place to eat at? What is a good hotel to stay in? Or you need a doctor, you ask around friends and family and what have you. But the whole online revolution and the social media took this whole concept to a different level, right? There's the online word of mouth now is known to be the #1 source that people go for when they're about to make a decision, and that doesn't seem to matter whether the decision is a low impact decision or a high impact decision. According to a UK-based study, as a matter of fact, 92% of the people happen to think that word of mouth information that is online from complete strangers is more important in their decision making than family and friends. So clearly there is a lot of emphasis put on what people say online in different forums or in different venues. So our angle here is that because there's so much online information and because people seem to be putting a lot of emphasis on it, the economics of information gathering and processing the information and the value you get out of it, that trade-off is more interesting now than it was ever before. And that's because it's a big data problem. Because online word of mouth confirms the definition of big data. There's a lot of it, it's not very structured, and it grows in size in a very short amount of time. So one remedy to deal with this kind of big data problem that is used by all of us is the cues, more specifically star ratings that are provided by peers, other customers or other clients or other people that patronize the same kind of service or product as a remedy, right? So we're going to go to a city, we're looking at hotel ratings, and before we read the reviews, we look at the ratings to see which ones we want to read, because it's virtually impossible to read everything that's out there. But the problem is that there are alternatives to these kinds of reviews. In other words, word of mouth doesn't only come from peers in the form of customer reviews. So what about, for example, reviews provided by experts? How about those kinds of word of mouth which is not in the form of traditional reviews, but in the form of blogs or tweets, and that could also be from other consumers or experts. Or how about partial reviews, in the sense that when there's a complex product with a long review, what if what we're interested in is only part of that product? And how about that part of that review that we're interested in? How can we get a quick judgment on what to read and what to make of that part of the review? For example, in complex consumer electronics or car reviews and what have you. So for this kind of word of mouth, there is not many traditionally developed cues that people can use to sort this large information space. Okay. So sentiment analysis is supposed to be something that you can use for this kind of problem. So a quick definition is that basically sentiment analysis text analytics technique by looking at words and in their context and in how they're placed in a sentence, we try to get an idea about the tone of a sentence, and from that we can go to larger paragraphs or an entire text. Right? So in its most basic form, which by the way in here we're not really trying to improve on the state of the art, but just to apply it. But the state of the art works as such. You just feed a document into one of these algorithms, what you get is a score. On one extreme, you get a negative score, -1, in many cases scale to -1, which means is that this review is very negative. On the other extreme, you can have very positive reviews and neutral reviews or anything in between, right? So as such, sentiment analysis or opinion mining today is one of the most frequently studied topics in computing. Many people are trying to improve on the accuracy of predicting the tone of a review or any text for that matter. So having said that, the majority of the research is on algorithm development. How can we predict these sentiments or people's opinions better, right? And most people seem to be focused on that. And there's very little empirical finding really on the impact of this technology, the so what question. Okay, so what if we can get the tone of a review or a blog with high accuracy? What do we do with that? So our interest was in the use of such cues, such additional support, let's say, from text analytics on making decisions. And the area, like I said, we are interested in is consumer decisions. So this study is about not what sentiment analysis can do or how it can be improved, but what its impact are on everyday people. Okay. So for that, so basically our working proposition in this study is because they are additional cues, just like star ratings, their existence in addition to the regular review should improve decision-making outcomes. Not necessarily the processes, but the outcomes.
So, actually, probably was going to say this next, but what's a purchase decision outcome? Is that
okay, yeah, I am about to get to that. Yeah. So maybe I should. Well, no, let me just get to it in a second.
Yeah.
So, very quickly, the theoretical conceptual background this is based on is the information foraging theory by Piroli and colleagues from Xerox PARC way back, which basically said, it's based on anthropology, which says, and biology, and which says, you know, when animals forage for food in nature, they go for cues, smells or different colors and what have you, and people do the same thing. So the richer the environment is with these cues, they go to what they're looking for quicker and more efficiently. So the whole idea of a design of such support systems, such as sentiment analysis-based decision support, is to provide richer cues so people can get what they want quicker, right? So, back to David's question. Without talking a lot about how we built this conceptual model, this is in a nutshell what we're looking at. We are looking at a comparison between reviews only and reviews supported by sentiment analysis score. And the decision outcomes that we're interested in is how efficient this decision is, meaning how quickly a decision maker can make this decision, and how confident they are in their decision. Now, why are we looking at what they make is the right decision or not? Simply because in this kind of consumer purchase decisions, there is no one right answer, right? If there was, then sooner or later, market will bring that, force people to, or bring people to that one equilibrium point where only the good products or the right decisions remain. Whereas here, it's a matter of preference. So how we can measure outcomes then is about subjectively how people are comfortable with their decisions and how confident they are, and how much time they can save in making that decision.
So one thing you could look at beyond this though is, I think in marketing literature, they use post-purchase satisfaction.
Now, which is kind of like what we looked at here.
Oh, okay, because I mean, that would just say, I'm sure that I made, I'm sure I made the right decision, but it doesn't go back later and say.
I have it on me, we can check the constructs, but I think we looked at literature, and this basically reflects some of that. There's a bunch of constructs that are collapsed into one thing here.
Okay.
So, yeah.
It's not basically after purchase gathering information. It was basically when they make the decision, how confident are they?
Okay, so that might.
There's no real purchase because it's experimental, these are.
It was not a real data gathering, it was only like a session.
Sure. Okay.
Yeah, but I think I get that. So, as such, we have some control variables that are again based on literature. A number of user characteristics and contextual variables are hypothesized to moderate this relationship, such as people's familiarity with the subject. And the more familiar they are, the less additional cues they need, because they actually have that, the background they can bring into that decision. Literature seems to suggest some gender differences. Females tend to place more emphasis on what others think. So that, in essence, we theorize that to be a moderating variable. And education level. The more educated people are, the less others' opinions seem to influence their decision making. So we think that these are going to moderate this relationship. And of course, people's intrinsic abilities, the most simplistic of those, their reading speed, should affect the time to make a decision. And indirectly, I think this is what that means.
Yes, indirectly.
Well, so yeah. And their confidence too, because technically, we're going to check this later, but you would think that if something saves you time, then you would overall have more confidence in that decision and have more satisfaction. So this is the conceptual model in a nutshell. All this comes from different, all these pieces come from different studies and literature, which I'm not going to go into, but that's basically what we tested. How we tested is in a user's, in an experimental setting. For that, we used Lexalytics as the sentiment analysis tool. What this is one of those many tools, and most of them are open source in the market. But many of those tools, like I said, since we're not interested in algorithm development, we actually want to see the success of the state of the art, which there's plenty of. But our first observation, which is not very hard to obtain, is that most of these sentiment analysis tools are made for shorter texts, typically tweets. I don't know what it is, but sentiment analysis seems to be almost analogous with tweets, right? Many of these studies and tools are for tweets. There are relatively few such tools that would be good for longer text. And Lexalytics and Limbics seem to be two of those. If you look at the literature, there are those that people think are reliable and they have been adopted by others. So what we did was then we compared these two to see which one to pick. And what we found was the correlation of the results that they generate, the sentiment analysis scores, are highly significant, which means they're replaceable. And there's not a whole lot of difference in the distribution of the scores either, so the chi-score is insignificant. So we could have picked anyone, and we just, for other reasons, which is the ease of use and what have you, we picked Lexalytics for this study. And then what we did was this. What we did was see how successful Exalytics can predict star ratings for data that we know there are explicit ratings. Because what we're going to use this on is data that there are no explicit ratings, right? But to test it first, we wanted to see how successful it is in predicting what people explicitly rated on their reviews, right? So we took 10 data sets in different domains. And we saw that 9 out of those 10 test sets, the star ratings and the sentiment analysis scores are significantly correlated, which gives us confidence that they can be replaced, right? Because star ratings are established. They are used. We know that people place a lot of emphasis on those. And this tells you that, maybe sentiment analysis scores can be used just in the same manner. But then when we look at the distribution, we see that the distributions are significantly different in 7 out of our 10 test cases. To be more specific, what star ratings have and the sentiment analysis scores didn't seem to replicate was the data at the tail ends. Very positive and very negative ratings. Sentiment analysis technology seems to clump things more in the center. And that is a problem simply because past empirical data shows that people are actually more interested in those extreme ratings more than anything else. Those are more important cues. So what we did for that was we basically took our distribution and stretched it. What we did was we took the slightly positive things and made them more positive. And slightly negative scores, we made them more negative. We use a very brute force method for that, and that is to be worked on. But we were able to make it more like the star rating distribution. And as a matter of fact, when we checked that transformed version of sentiment scores, the chi-score showed no significance, which means the distributions became more similar. Right? So that was the pre-processing of the data before we use them on text, word of mouth, where there's no star ratings. So now this is our only cue that we're going to present to the users. That word of mouth data was 80 pages of reviews on 3 consumer electronic products, more specifically digital single lens reflect cameras. And the 80 pages of reviews were a combination of expert ratings as well as peer ratings or user reviews and sorry, not ratings, reviews. And these 3 cameras were picked from compatible and legitimate alternatives, meaning these are all popular cameras and they're considered in the market as substitutes for each other. So we try to make this a realistic of a purchasing scenario as possible. And the reason we picked digital cameras is that these are important enough purchase decisions that people would need additional cues before they make a decision. Meaning if we did this for toilet paper or diapers or what have you, probably people wouldn't care what others think because there are very few attributes you have to consider and you can just directly look at those yourself. On the other extreme, if you went to purchase of a house or a car, that is a much more complicated decision that you couldn't possibly capture that process in a 1-hour experiment. So we wanted to be in a space where the decision is important enough, but it's doable in the amount of time that we gave people. And it's kind of consistent with other studies in similar domains. And to attract users, which because we ran this in our university, most participants happened to be students, although it was open to everybody. But nevertheless, it was mostly off times, and people had to come and spend some additional effort and what have you. We gave everybody that completed the whole study a $10 honorarium for the appreciation of their effort. Okay, so at the end of the day, 100 people finished the whole study. So that's the sample that we under 70, we eliminated 70 for, yeah. So 100 of them was the useful sample. And when we compared those that get the sentiment scores along with the reviews to those that did not get those scores, as far as the decision speed or the time it took to make the decision, there was not a significant difference. So in our study, we failed to capture, if there is an efficiency benefit, so to speak, we could not capture that. We could not detect that. When it comes to hypothesis 2, things were a little bit more nuanced in the sense that the effect of the decision 8, which means reviews only or reviews versus sentiment scores, happen to depend on gender. There is a significant moderation effect, right? Although the main effect is not significant, this suggests that we should test this hypothesis gender specifically. And when we did that, for males there was no significant difference, but for females we found that whether we have sentiment scores along with reviews actually makes a difference. In that people, or I should say women, who got the sentiment scores along with the reviews happen to be much more confident in their decision at the end of the day than those that didn't. And that was a very pronounced difference. I mean, it's fascinating how much things can change with one specific, one little intervention, so to speak. So that's promising, although we couldn't find support for the whole model. Sentiment analysis shows promise when there are no other cues to navigate big sets of opinion-based data, at least for a group of people and for this setting. Right? So one practical suggestion out of this then is that female-oriented product size can integrate sentiment analysis tools. It seems like it influences female consumers more than males, which is, again, is consistent with prior literature that says, you know, it should work better for women. And all the psychology and consumer research points to the same direction as well. But this is just the first attempt in understanding what sentiment analysis can do for real decision making. So, in that sense, the effect of these scores may be one, weak to moderate, which means we need a larger sample, which means more large-scale studies, which this was hard enough to get. Yeah, how many sessions did you run? Yeah, so many sessions just to get this many useful data points. So it is going to take time. But we're thinking actually things were in the right direction, except that they're not pronounced enough. So a larger sample replication study can reveal if there are any more effects to be captured. And the other thing might be that the effect of scores is actually context specific. There is a concept of more sentimental products or sentimental services where you would think that the sentiment scores would be more effective on. Cameras are pretty blunt, right? People don't attach a lot of sentiments or mood to those. So whereas other kind of selections or decisions, as in selection of a doctor, especially for a serious condition, or a school to go to, these are much more emotional decisions. So, but at the same time, in an experimental setting, these are hard to replicate because we really cannot put people in a situation where they pretend to be looking for a doctor. So we need to think about how to run those experiments, but it is quite possible that the effects would be much more visible in settings like this. So that leads to the whole idea of creating a more comprehensive conceptual model to be tested, typically, especially using theories of fit, more specifically the task technology fit, which pretty much claims that, you know, the effect of technology is tasked upon. In this case, the task can be what you're trying to do and what kind of context you're using, and also some more of the user characteristics. We use gender and education level and familiarity, and these are the main ones, but we should look deeper into the literature to see what else matters, right, as far as the decision maker. Because there is, for example, age might matter, and as a matter of fact, it is known that older people care less about what others think than younger people. But we couldn't catch that variance in our sample. most people were students, so it's the typical 20 to 25 age group. If you can stretch it out to, say, and there are many interesting studies in senior citizens, for example. If you can capture some of those guys and put it in the sample, that might give us some results that we weren't able to really obtain here. And the third piece is the HCI aspect of it, the presentation of this information. What we did was we presented sentiment scores and we used color, and that was it. But typically people are used to seeing stars, so a very easy adjustment would be just to present sentiment scores as if they're stars, to see if that makes a difference, because people are more used to it. Whereas sentiment scores that go to 3-digit significance, that may have thrown people off because they're not used to seeing that. It's a little superficial to them. Although it's more precise, right? We're giving them exact, or maybe not exact, but much more precise values as opposed to 3-star versus 4-star. But then again, if that's the expectation, maybe we want to play around with that and other different color codes. Because people associate different colors to different emotions, and we didn't think very thoroughly as to what colors to code these sentiment scores with. So that might be another thing to experiment with going forward. Okay. So this is all I have to say. I think I'm just about to run out of time, so I can take a few questions if you have any.
Yeah, a couple of questions relating to this sentiment analysis. One is that in the real world, you've got two confounding factors. One is irony. This was the most amazing product, 0 score, which is quite difficult for machine mechanisms to catch. The second one is the long-known factor that I have bad service, I will tell 10 people, and I will blog, I will, whereas I'm happy, satisfied is what I expected. I might, if I'm really happy, tell 3 people, and I probably won't get around to blogging or putting a rating. How's that going to work?
How do we deal with that? Okay, so the second question I think is easier, because that happens whether you're using sentiment scores or ratings, right? Mm. So when you compare, so because we use sentiment scores as a replacement or substitute with star ratings, so whatever the effect is, it's going to be there, whether it's explicit or implicit as in our case. Not to say that that's not an issue, but it's something that is probably harder to deal with. As far as the irony, sentiment analysis or opinion mining, researchers are working on that. And there are some progress that is made. Maybe Parisa can talk more about it because she looked at that literature. But the technology is getting more sophisticated trying to capture that. But it is an inherent difficulty. But the problem is when people need something, they still, that review has no effect on people if they don't even get to read it, right? So anything that gets them to read it, maybe without the star rating, maybe they actually see it for what it is. Maybe we just label it as very positive, but it's actually negative. But nevertheless, people get to read it. And it's still, chances are when there's irony, it's one extreme and we're detecting it as the other extreme. But if we can capture it and knowing that people read the extremes, maybe they still get to read it and judge it on their own, right? Whereas without it, it may just simply not be seen. I guess that's my short answer to that's a really complicated question.
In hypothesis testing, I guess you consider alpha or level of significance 5%. Is there any specific reason to select?
Standard in social science management research. I'd rather have a larger value, but you can't get away with it. So instead of the 0.05. But yeah, what we found in our defense though was 0.01 and even lower than that. So I think it's significant however you look at it, but it's only that one hypothesis is partially supported. So we're confident it is supported because it's a very significant finding, and we don't claim that anything else is supported. So I think that choice of P in our case is not that relevant, but in any case, that's the standard that goes. So that's where we start. Okay. Well, thank you very much. With that, I turn it over to David.